This is a tutorial on the division properties of exponents. Whenever we divide two numbers with the same base but different exponents, we can just subtract our exponents. Let's look at our first example here. We have 4 to the 4th divided by 4 squared. If we expand this out, 4 to the 4th is 4 times 4 times 4 and then times 4 again. And this is divided by 4 squared, or 4 times 4. Now, two of these 4's will cancel with what's in the denominator, because 4 divided by 4 is just 1. So what we're left with is 4 times 4, or 4 squared. Now, if we use the properties of exponents, when we divide, we can just subtract our exponents. So if you have 4 to the 4th divided by 4 squared, you can turn that into 4 to the 4 minus 2 power, or 4 squared, which is what we got before. Now, when we were using multiplication properties of exponents to solve problems like this, we were converting our denominator into a negative exponent. So if we have 5 squared here in our second example, 1 over 5 squared is the same as 5 to the negative 2. So we were converting this into 5 to the 5th times 5 to the negative 2. And when we multiply, we add our exponents. So this would be 5 to the 5 plus negative 2 power, or 5 cubed. Now when we divide properties of exponents, we just subtract our exponents as long as we have the same base. So to solve this that way, this would convert into a 5 to the 5 minus 2 power, or 5 cubed. Notice that this is almost exactly the same as when we multiplied. So whenever you see two numbers with the same base, with different exponents, all you have to do is subtract the exponents. So here we have 7 to the 7th divided by 7 to the 4th. This will become 7 to the 7 minus 4 power, or 7 cubed. And this works the same way with variables. Here we have x to the 5th divided by x cubed. This will turn into x to the 5 minus 3 power, or x squared. So again, whenever you have two numbers with the same base and different exponents, and they're divided, then you can just subtract your exponent. Now, whenever you have two numbers divided by each other, and they're both raised to a power, remember that you can distribute this power inside to each number. Or if you have a fraction to a power, remember each part of the fraction is also raised to that power. So 3/4 to the 4th is the same as 3 to the 4th over 4 to the 4th. Well, think of this as 3 to the 1 over 4 to the 1, all raised to the 4th power. When you take a power of a power, you always multiply the exponents together. So this is the same as saying 3 to the 1 times 4 over 4 to the 1 times 4, which would get us the same answer, 3 to the 4th over 4 to the 4th. So we can follow these same steps to evaluate when we have powers to a power. Here in this example, we have 7 to the 4th divided by 7 squared, all raised to the 4th power. So if we distribute this outside 4 here into both sides of this fraction, we would end up with 7 to the 4th to the 4th over 7 squared to the 4th. Now we have a power to a power, so we need to multiply our exponents. So 7 to the 4th power would be the same as 7 to the 4 times 4 power, and that's divided by 7 squared to the 4th power, or 7 to the 2 times 4 power. This is equal to 7 to the 16th over 7 to the 8th. Now remember, when we have two numbers with the same base but different exponents, we subtract our exponents. So this will further simplify into 7 to the 16 minus 8, or 7 to the 8th. Now again, the same thing works with variables. If I have 2x y squared divided by 3x squared y, all to the third power, then I can move this third power to both the numerator and the denominator. So this is the same as 2xy squared cubed over 3x squared y cubed. Now again, when you take powers to a power, you multiply your exponents. So this will further simplify into 2 cubed times x cubed times y squared, and then cubed again, all divided by 3 cubed times x squared cubed times y cubed. Now 2 cubed is 8. X to the first power and then to the third power would be x to the 1 times 3 power. Y squared and then cubed again would be y to the 2 times 3 power. And this is divided by 3 cubed, which is 27, x squared and then cubed again, which would be x to the 2 times 3 power, and then y to the first power, and then cubed again, would be y to the 1 times 3 power. So this will simplify into 8 times x to the 1 times 3 power, or x cubed, y to the 2 times 3 power, or y to the 6th, and that's divided by 27 times x to the 2 times 3 power, or x to the 6th, and then y to the 1 times 3 power, or y cubed. Now we still have two sets of numbers with the same base. We're dividing an x cubed by x to the 6th. And we're also dividing y to the 6th by y cubed. So this is going to simplify into 8/27 times x to the 3 minus 6, because remember you subtract your exponents when you divide with a similar base, and then multiplied times y to the 6 minus 3. Well, this is going to become 8/27 times x to the 3 minus 6, or x to the minus 3, and then y, 6 minus 3 exponent would be y cubed. Now we're almost done. Our x to the minus 3 here is a negative exponent, so we're going to put that in the denominator, and we're going to end up with 8y cubed over 27x cubed. And that would be our simplified expression.